Hello, I'm Morgan McKee and I'm a chemistry master's student at Swansea University, and I've been asked to do a presentation on hydrogen fuel cells for you. I'm going to give you a quick overview. So firstly, we're going to speak about the principle of fuel cells, then the hydrogen half cell, types of hydrogen fuel cells, specifically two types, the alkaline hydrogen cells and the acidic hydrogen cells, and then finally we're going to speak about the pros and cons of hydrogen cells. So firstly, we're going to discuss the principle of fuel cells. I like to ask myself the question, what is a fuel cell? A fuel cell is an electrochemical cell that converts chemical energy into electrical energy. This requires a fuel, often hydrogen, and an oxidizing agent, such as oxygen, to undergo a redox reaction. There are many types of fuel cells, but they all contain a cathode, anode, and electrolyte. So if we have a look at the diagram, we can see that the hydrogen is at the anode, and this is where the oxidation process occurs, whereas the oxygen is at the cathode, which is where the reduction process occurs. And the easy way to remember this is red cat and ox. So this is the reduction cathode and anode oxidation. You can also see on the diagram, this means that the anode transfers electrons to the cathode, and the other way to remember that is the way I used to remember it is oil rig. So oxidation is loss and reduction is gain of electrons. So firstly, I want to speak about the hydrogen fuel cell, half cell, sorry. These cells typically use a platinum electrode, and this electrode is submerged into a 1 molar strong acid solution such as HCl. Once in the solution, hydrogen gas at 1 atmosphere is then bubbled over the electrode to produce the H+ ions to give this half equation. Hydrogen goes to 2 protons plus 2 electrons. So now we're going to move on to the types of fuel cells. There are two main types of hydrogen fuel cells. As I stated earlier, these are the alkaline hydrogen fuel cells and the acidic hydrogen fuel cell. The main difference between these two is the flow of ions that facilitates the redox reaction. So if we go back to this diagram over here, the electrolyte is the part of the fuel cell that facilitates the flow of these ions. In this case, you can see it's H+, so this would be an example of an acidic hydrogen fuel cell. So if we start off with the alkaline hydrogen fuel cell, hydrogen and oxygen flow into the cell and water flows out. The electrolyte in the center of the cell allows the flow of OH- ions. So this is a standard kind of diagram for a hydrogen fuel cell. We have our hydrogen and oxygen flowing into the cell, with the hydrogen at the anode and the oxygen at the cathode. We then have water coming out, and we have OH- ions traveling through the electrolyte from the cathode to the anode. So we now need to consider the half equations and full equations for this reaction inside of the fuel cell. There are two half equations, so we have 2H2O plus 2E minus going to H2 plus 2OH minus, and then we have a half O2 plus H2O plus 2E minus going to 2OH minus, where the top equation happens at the anode and the second equation happens at the cathode. So now we need to combine these two equations, and how we do that is we flip the top equation and add the two equations together so that the electrons cancel out. This gives the full equation of half O2 plus H2O plus H2 plus 2OH minus going to 2OH minus plus 2H2O. Now, as you can see, we have common parts on both sides of the equation, and this means that the 2OH minus can cancel out, and we have one water cancel out. This leaves the final equation of a half O2 plus H2 going to H2O. Now the acidic hydrogen fuel cell still has hydrogen and oxygen flowing into the cell and water flowing out, but the electrolyte in the center is now allowing the flow of H plus ions. So we still have the same diagram. So we still have hydrogen and oxygen flowing into the system and water flowing out. But now we have H plus ions going from the anode to the cathode, which gives a whole new set of half equations. So the half equations are now 2H plus 2 electrons going to H2, half O2 plus 2H plus 2 electrons going to H2O. Now if we do the same thing, if we flip the top equation and add the two equations together, we now have this. Half O2 plus 2H plus H2 going to 2H plus H2O. Now as we can see, once again, the 2H plus cancels out, giving us the same overall equation, a half O2 plus H2O plus H2 going to H2O. So what are the pros and cons of this reaction? Well, the pros, they are more efficient than burning of fossil fuels, which are currently damaging our environment and atmosphere. They only release water as a waste product, which is a non-hazardous substance, which is also a massive benefit. However, they require energy to be built, and energy is required in the production of hydrogen, such that our main production of hydrogen is something called grey hydrogen, which is through the combustion of methane, which isn't viable because it also produces CO2. So this means that even though these cells are more efficient than the burning of fossil fuels, the energy required to produce the cells and hydrogen comes from fossil fuels themselves, meaning that there is an inadequate energy gain to loss ratio. So to summarize what we went over, we discussed the basic principles and types of fuel cells. We discussed two types of hydrogen fuel cells specifically, including alkaline hydrogen fuel cells and acidic hydrogen fuel cells, where alkaline hydrogen fuel cells, the electrolyte facilitates the transmission of OH minus ions, whereas the acidic hydrogen fuel cells, the electrolyte facilitates the flow of H plus ions. And then finally, we discussed the advantages and disadvantages of hydrogen fuel cells. Thank you for listening.